Hey, welcome back. Let's take a look at scientific notation. This is used very often in science to denote either very large or very small numbers. Here's an example of a number that you could see. 3,567. This is a very large number, not as large as it can be, but a shorter way to write this number would be to use scientific notation. So the first thing we're going to do is put a 1 decimal after the first digit, and then we'll follow up with the rest, and it will always be multiplied times 10. Now, the number of times we had to move the decimal place to get to this place will go as a power of 10. Large numbers will have positives, small numbers will have negatives. This is a very big number, so it will have an exponent that is positive. So, how many places did I have to move to get to this decimal place? 1, 2, 3 places. 3 places to move to get to this format, which is always the same. Number, decimal place, rest of the numbers. So because I moved 3, I put a 3 in the exponent of 10. Now let's take a look at a larger number and a situation in which we are going to have to apply significant figures. So I have 3,500,000. So 3,500,000 does not have a decimal place at the end. That means all 5 zeros are not significant. So they will add to the magnitude, but they will not be recorded in the notation. So I will include these in the magnitude. So as I trace my decimal place forward to make 3.5, each one will count. So my decimal goes right there. 3.5, 1, 2, 3, 4, 5, and I had to go a total of 6 places forward to put the decimal place where it belongs. When I report it, once again, I will leave off those zeros and just report 3.5 because those zeros were not significant. They were just for the size of the number, and I will put a 6 as the exponent. Now, what happens if my number is very small? Okay, so the same idea. I'm still going to have a number, a decimal, and then whatever numbers are left. So as I look at this, I see there are zeros in the front. These zeros are not significant. They just show us how small 63 really is. Okay, so I will follow the same idea as before. Count 1, 2, 3, 4, 5. I had to move 5 places to get my decimal where it needs to be. 6.3. And since this is a small number, not a large number, small numbers have a negative as their exponent. Okay, so I would not write 5 here. I would write -5 because this is a small number. So 6.3 times 10 to the -5 would be the scientific notation for this number. Okay, let's write a number that has more digits in it, but is also small. So here we see the same zeros in the front. And now we see that we have several numbers after the first two. 1, 2, 3, 4, and this 0 matters because of significant figures, once again, on the other video. Okay, so this is actually real. So now I'm going to count backwards. 1, 2, 3, 4. So 6.3560. Then I write all the actual numbers after that and the zeros that matter. Okay, that 0, once again, is significant. So now I'm going to write it times 10. I know that my 4 is going to be negative because it's a small number. That's it. See you next time. Bye-bye.